Alright, it's your boy the Knologist. We're going to be doing letter combinations of a phone number. This is a medium Leetcode. And let's see, given a string contain digits 2 to 9 inclusive, return all possible letter number combinations that the number could represent. Okay. Return the answer in any order. A mapping of digits to letters just on the phone buttons is given below. Note this one does not map to any of the letters. Okay, cool. Just tells me right away, make a dictionary and map the number to the letters. So I could do a dictionary in string, because I could do an array, but I could also just do a string. So for example, stores, boom, that's an array. Stores, ABC, 3, DEF, 4, GHI, 5, JKL, 6, OPQ, MNO, MNO, PQR, PQRS, TV, DUV, and then WXYZ. So it's 2 to 9 inclusive. Okay. Digits length could be 0 to 4. So then my output's got to be return all possible letter combinations that the number could represent. Return the answer in any order. Okay, cool. So I need to create some sort of list of strings. Given a string containing digits 2 to 9, okay, any order, okay. Oh, and it looks like the digits is an input string. So we have to turn all this into strings. Okay. Everything's a string. Let's get the possible combinations. One, two, three, four, five, six, seven, eight, nine. This is gonna be like exponentially huge. That's why we only do a max of 4 digits. You could have a length of 0, so automatically just return an empty list like this. So I can't do 4 loops. It would just take too long. Right, it's 9 for just 2 numbers. So 3 would be like 27, and 4 would be like 250, or some shit like that. But you could do it where it's length 0, you get this, length 1, you get all the letters, length 2, and then length 3, and then length 4. You can make a loop for each one. There's got to be another way. Let's try and break it down on the whiteboard first. Okay. Let's just do D equals 2, 3. That's A, B, C, D, E, F, 2. A, B, C, D, E, F. Digits, this is the letter in combination. So then first I want to go A. So I want to go A. With D. A with E. So this, then this, then this. Then we go B. E. F. And we go C with D, E, F, 3, 3, 3 equals 9. So it's safe to say that for the most part, whatever the power is, except unless it's number 987, where you get 4 letters, it'd be 3 to the power of 3 and times 4. Digit 23. I'm thinking also, instead of 2 separate strings, I just add the strings together. And based on the length of this, I want to find all the combinations. I think that's the way I want to go. So for example, this is the long way of doing it, and now I want to go to the easy way. So it would be ABC plus DEF ABCDEF, right? And then this length, I want to find combinations of that length for ABCDEF. So find possible combinations, Python. Iter tools. So find combinations is a method. So name of iterator and length. Best suited, name of iterator. So for example, let me see. Okay, I need to figure out how to get combinations. There's got to be a function. Generate all combinations of a list. All possible combinations. All possible combinations. So where is it? List combinations are for. So list combinations combinations. So let's find it. Combinations are length tuples in sorted order, no repeated elements. So product combinations would be AB, AC, AD, are length. Okay, so it's the combinations, and I have to import iter tools. So let's go import iter tools. Okay. Then whatever the digits are, I created stores with the actual digits. Then I want to turn that digit into a list of strings. Temp is an empty string. For digit and digits, temp. Temp plus equals digit. Stores digit. So let's say it's 2, it's going to be ABC, ABC. Doesn't matter what order it's in. And then what I want to do is I have the iter tools array. No repeated elements. combinations. So P iterable and R combinations Python. I'm at 26 minutes. I just want to figure out how to use combinations. From itertools import combinations. Stores digits. I don't even need to store that. I can just put that here. And whatever the string is, I add it. And then I go length. So ARR. This is the string iterable. It's going to be a list of combinations. So combinations is going to be temp. We'll call this combo list. Combo CMB list. So combo list is going to be what's called, it's going to be combinations. It's going to be a list combinations of temp, which is the new string iterable that I'm going to go over, and then it's going to be len digits. So if it's 2 digits, combinations of 2s, 3 digits combinations of threes. Right, so that should spit out a list of tuples or whatever the frick it is. And then I want to go final. Return list of all subsets of R. To deal with duplicate subsets, use set list combinations. I might have to test this on Python Playground. Let's go to Python Playground. I just want to see what the output is first. Okay, parameter tools, combination, cool. Okay, so now I can get rid of all this, and the return I'm going to go print. So this I'm going to shift tab, self digits, so I'm going to say digits equals 23. I'm going to delete this, and I'm going to have my import up here in this. Combinations, iter-tools, combinations on iter-tools. It's literally on iter-tools. Len digits. Why? Oh, because there's an extra bracket. That's probably why. Okay, CMB list. Bad input. List. Iter tools temp. First, let's print temp. I just want to see what's going on. EOF, okay, so line 29. Okay, so I got close, but clearly I'm doing something wrong. Python Playground's not recognizing this. So let's ChatGPT it. How much time do we got? That's about near 40 minutes. That's fair. To unnecessarily dig is just a waste of time. So let's use the time effectively. ChatGPT. Instructions. My code. Fix my code. Combinations function for the iter tools. But the problem for this, we need to generate all possible permutations, not combinations. Okay, so I just use permutations instead. It's not a big deal. Function for backtracking. Oh, so this is some sort of recursive backtracking problem. So if not digits, okay, cool. Same thing, same thing. So what does the backtracking portion do? So Python combinations to hold this. If the path is the same length as digits, we have to complete the combination. So if index equals the length of the digits, combinations that append path, and then return possible letters, stores digit index, stores digits digits index. So with the 0th index, it goes then 1 index. Okay, so it's basically doing a backtrack to make sure I go to every combination of letters. So it's like recursive backtracking, but with a string type question. The backtrack method actually looks like it makes more sense to me, because the one with the for loop's a bit weird. So now we have temp. So this is all the same, then combinations. Okay, so then it says create the helper function, def backtrack. And this is index 0 path, and then you add it to the empty string, which is what happens, what we were doing earlier. It just does it all in one step. So comb for combinations. So backtrack index path. If index equals the length of digits, combinations.append path. We have complete combination. Combinations.append path, and then return. Get the corresponding letters to the current digit. So positive letters stores I need to access the map. That's why they put this inside. Okay, so X. Possible letters. Stores index, and then 4 letter impossible letters. Backtrack, and then index plus 1. And then path plus letter. So that way you build and you get all the combinations of that path on the way. Index plus 1, path plus letter, index plus 1. Index plus 1, path plus letter. It's the 0 index and empty path. Stores digits index. That's why digits index. You can't just go stores digits. You have to go by 0 and then 1, 2, 3. And there you go. Use recursive backtracking to solve for this issue. And this is better than doing 4 for loops or whatever the hell. And it beats 30.17% of solutions. So basically what you do is you create, because you could have 0 digits, a length of 0, return empty list. Otherwise, create the stores. So you have to basically create this mapping of the string of the number to the letters associated to that number. So 2, A, B, C, 3, D, E, F, and then so on and so forth. Then you got to create a combinations array where you want to store all your combinations. So now you want to go backtrack. So we have index and a path, right? So we want to take the first letter, right? And then we want to basically increment the index so we can match it with every single item. Then go on to the next letter, increment the index. Go on to the next letter, increment the index. Alright, so it's going to be path plus letter. And at the end, when you get to the final index, you append the path. And as you can see, we started at 0 index. So you want to start the first letter and then build with the rest using this backtracking method. So it's like first letter, boom, 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 build. Second letter, boom, 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 build the path. Third letter, boom, 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 build the path. Then you get A, D, A, E, F, A, F. Then B, D, B, D, B, F. Right? Because you're going for each letter in possible letters. Alright, so when you do that, you want to check each combination of the letters in order of that possible letters string, because it stores digits.index. Right, so you're pretty much building the path at that stores digits.index based off what those letters are. So you go A, boom, 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 B, boom, 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 C, boom, 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 boom. Then you go to the next one, and then you combine your letters to create these combinations of letters here. So this this passes the submission and the test cases. So if you like this video, please give it a thumbs up, subscribe, comment below. Knologist out.